Hello, good evening or good morning, everyone. My name is Yonghan Deng from Wisconsin School of Business, University of Wisconsin-Madison. I'm the chair for today's session, Macroeconomics, Policy, and Urban Economics. Today, we also have our ABFER Real Estate Program Director and Program Session Organizers, Professor Sheridan Titman from Texas, Austin, Stein Van Nieuwenburg from NYU, and Tian Fu from NUS join us in the session. Sheridan, Tian Fu, and Stein, do you have a brief message or greeting to the audience?
Sure, just wanted to say hello to everybody. Welcome to the real estate session. We're very excited with the strong submissions and look forward to the program.
And I'm also looking forward to the program. So,
right, thanks, Johan, for chairing the session. Also, all the participants. I'm looking forward to hearing.
We have 4 papers today on a very exciting topic. I will ask each presenter have 30 minutes in presentation. I will give a 1 minute warning, and then discussion following Stein's rule as 10 minutes, so we can save 10 minutes for general discussion. We start with the first paper. Presenter will be Yusuke O. The topic is Nowcasting economic activities with mobility data. Yusuke, you have 30 minutes.
Hi there. So let me share my slides. Okay, so let's get started. Hi there, I'm Yusuke from Bank of Japan. I want to thank you all for having me on this session today. And I'm really excited to share with you our research about the application of mobility data for macroeconomic nowcasting. So our study is motivated by the pandemic, namely the importance of evaluating economic condition in a timely manner has been extremely important. The official statistics, however, won't tell us much about the situation of current economy, so it is natural to try to find non-traditional and high-frequency data to address this issue. Well, in this paper, we focus on GPS data and constructed indices aiming at nowcasting traditional statistics. Basically, by combining GPS data with other data telling us what types of facilities locate at each place, we examine on what industry and which sector the GPS data can provide information about economic activities. It turns out for some sectors, GPS data is quite useful for macroeconomic nowcasting. Next, I will briefly talk about the literature. 2 strands of literature can be related to our study. One focus on the application of human mobility data, and the other is about macroeconomic nowcasting. In the first strand, Couture et al. 2021 developed indices that basically quantify movements and social contacts. Watanabe and Yabu 2020 developed stay-at-home index and examined the mechanism through which the government's policies have led to changes in people's behavior. In the second strand, Kajina et al. 2019 used payroll data from ADP and measured the deterioration of the US labor market the pandemic caused. Prigliano et al. 2019 used B2B and B2C payment data for nowcasting GDP and its main components. The contribution of our study is extending the 2 bodies of literature, namely, we show the usefulness of mobility data as a tool for macroeconomic nowcasting. Next, I will briefly talk about the data. Our main data records estimates of hourly number of people at each place, called mesh. A mesh is defined as a non-overlapping 100 meter by 100 meter square, characterized by a pair of longitude and latitude of the center of the mesh. In our data, there are 20 million meshes covering all over Japan. So our data is essentially a huge panel data. The cross-sectional unit is mesh ID, places, and it has 34 billion records in total. It is easy to imagine that even though we know the number of people stayed in a certain place or mesh, we never know what they are doing without additional information telling us what the place is all about. If it turns out that a large portion of the mesh we are interested in overlaps with a big factory, then we can infer that people stay in that mesh is producing something. Or if it turns out to be a major shopping center, then the people in that mesh is very likely to be buying something. One important thing to keep in mind is the size of the mesh. In principle, this size plays the same role as the resolution of microscopes. Targets smaller than 10,000 square meters is difficult to see. So what additional information is available? It depends on the goal. When we try to nowcast production, the main data is economic census microdata. It records a number of features of factories, including their address, the number of employees and sales, etc. The address is always the most important information since it enables us to connect their identity with mesh ID. Second, the data from National Land Numerical Information provide us with the coordinates data of specific facilities such as stations and airports. Private companies may provide useful information about specific sectors as well. Suppose we are interested in measuring customers in restaurants, then restaurant guide service can be useful in correcting the addresses of restaurants. When additional information is not available, we have to infer from GPS data itself. Suppose, for example, the mesh we are interested in has an inverted U shape for hourly population distribution. So this implies people don't sleep in that mesh, then we can be sure that it is unlikely to be a residential area. Also, machine learning technique can be used in inferring the mesh identity. The technique we use is clustering. However, there are tons of cutting-edge techniques, and running a horse race among them is beyond the scope of this paper, so we want to leave this topic to future research. We refer to the index we will use for nowcasting as economic indicator from GPS, EIG. The construction of EIG is very simple. Given sector J, we first specify all meshes related to J. We denote IJT as this set of meshes. We then sum up population on IJT to get total pop JT with or without additional weight, which in production is the value added weight. Secondly, we normalize this index with respect to some reference point. Note that the EIG is hourly basis and can be further aggregated to any frequency. So far, I described the data and how to create the index. Next, I will show how to use these indices and how they compare to official statistics. Our first targets are service industries. It's the natural place to start with since in many service industries, the sales is directly driven by people who stay in the shops. Three sectors we think the EIG is promising are amusement parks, shopping centers, and restaurants. The key information again is what the place or mesh is all about. Basically, we use other source of data. Sometimes prior knowledge is quite useful as well in removing noise meshes. For example, we know that in a shopping center, the average number of customers on weekends on weekdays is unlikely to exceed that of the weekends. So we can safely remove meshes that violate this prior knowledge or belief when constructing EIG. One important thing to consider would be the size of the facilities. Imagine we are interested in how many people stay in a certain Starbucks coffee shop located in Tokyo, and we know in what mesh the coffee shop locates. But unless the site area of the shop exceeds 10,000 square meters, which is quite unusual, the mesh containing this shop will surely have population unrelated to the shop of interest. In this case, additional techniques are needed to extract the population fluctuations related to the shop or remove noises unrelated to the shop. Basically, such technique can be any cutting-edge machine learning methods, but in order to keep our paper simple, we applied a well-known clustering method in what follows. So let's dive into the results. Amusement parks are quite large in general, so we can manually identify all meshes overlapping with a certain park by checking the park on the map. Also, the number of parks is very limited, so it's feasible to do this on all major parks. The left figure shows the resulting distribution of hourly population. The density is relatively high in the daytime on weekends as well as on Mondays and Fridays, which is very reasonable if we think about amusement parks. The right figure shows the year-over-year change of the EIG aggregated at monthly frequency on selected meshes. The gray line is official statistics. Their positive co-movement illustrate the usefulness of GPS data. Our next example is shopping centers. This time, manually checking every shopping center on the map is infeasible because the number of facilities is large. Fortunately, address information of major shopping centers is made public by the Japan Council of Shopping. Also, we cannot be sure about whether or not their physical size is larger than 10,000 square meters. So it is possible for some meshes, even though they are on the shopping center list, the population fluctuation can be driven by irrelevant types of activities such as workers in business area or commuters in stations. We exclude such meshes using address information of stations provided by national non-numerical information. Also, we believe that the population in weekends should be larger than that of weekdays. So meshes whose distribution doesn't satisfy this property are also removed as irrelevant ones. The resulting EIG again tracks the statistics very well. In food service sector, the size of a restaurant is by far smaller than 10,000 square meters in general. So even though we can spot the address of every restaurant, further techniques should be adopted to remove unrelated population fluctuations. We use a well-known clustering method called K-medoid to disentangle activities taking place on pre-selected mesh based on restaurant guide service API. We supplied K, the number of clusters equal to 5, and examined the population fluctuation in each cluster. One cluster, which we refer to as cluster 1, exhibits reasonable pattern of hourly population. It peaks at noon and 7 p.m. on weekdays, implying this cluster successfully captured the visitors to restaurants. Looking at the actual performance, the EIG aggregate on cluster 1 shows similar fluctuations to our target indicator, JCB consumption now, which is a proprietary index for tracking consumption activities based on credit card data. So far, we go over the construction of our index and show their usefulness for nowcasting on service industry. There's one point I'd like to emphasize. One might suspect that the high correlation between EIG and target statistics can be the result of the pandemic pushing the EIG and economic activity strongly toward the same direction. However, we only use the data up to March 2020 and verify the performance is high even during normal times. The next application is industrial production. Basically, what we want to do is approximate the production function using only proxy for labor input. So it is natural to expect varying results depending on the shape of the true production function. Let's take a look at to what extent the production function can be approximated by ideal labor input. The table shows the correlation between industrial production and labor input obtained from offshore statistics. It is apparent that for nowcasting purpose, even the ideal labor input cannot approximate the production function in sectors like food, beverage, and tobacco. So we focus on sectors where the correlation is high, such as production machinery, transportation equipment. The target factories are determined as follows. Among factories listed in the economic census microdata, whose area are above 10,000 square meters, we focus on top 10,000 factories ranked by value added. The selection of meshes is a little bit complicated compared to service industries, even though we know the site area of each factory from census microdata. Sorry. Well, this is because the shape of each factory is unknown, so we don't have prior knowledge about how to correct meshes around the mesh containing the address. One heuristic approach we adopt is, first, we collect meshes square-wise, such that the sum of area of collected meshes exceed the site area of the factory. Second, we remove unrelated meshes in this set based on the distributional features. Specifically on the diagram, we want to remove the top 3 blue meshes whose overlap with the gray actual factory site is small by focusing on some key ratios. This figure shows the population patterns of typical factory area and the residential area over day of week and over 24 hours. You can easily spot the stark difference between them. On factories, the density is nearly 0 on Sundays since no workers work on Sundays. And within a day, it has an inverted U-shape and peaks at noon. The residential area has the opposite patterns. This implies that we can distinguish true factory meshes from unrelated ones by checking their distribution. One straightforward way to implement this idea is to set Sunday ratio upper thresholds and daytime threshold lower thresholds, such that the population aggregate on meshes satisfy these thresholds is highly correlated with offshore statistics measuring labor input. We also add a third measure, average population lowest threshold, to mitigate noisy meshes. The table demonstrates, for example, that in transportation equipment sector, the correlation between population and labor input is maximized if we set the Sunday threshold equals to 0.5, daytime thresholds equals 0.6, and the average population threshold equals to 10. The maximum correlation is 0.86. The aggregate factory-related population and the labor input display strong positive co-movement, implying the selection of meshes is not bad. Next, we want to use the factory-related meshes to nowcast the industrial production. Another complication is that the core working hour is likely to differ across sectors. In the same manner, we grid search 3 parameters determining the time window such that population aggregated on the window has the highest correlation with offshore statistics. For example, in transportation equipment sector, if we compute the sector EIG by aggregating population on factory-related meshes on the time window spanning from 5 p.m. to 6 p.m. and including holidays, the correlation with production is 0.85 and is highest. The resulting headline EIG traces the YOY change of the industrial production very well. The performance for specific sectors mixed as expected. It's good in transportation equipment and poor in electronic parts and devices. This could be attributed to, as we discussed earlier, the fact that the importance of labor input for production could vary a lot across sectors. Well, since the law data is hourly, we can also construct the indices at weekly, daily, or even hourly. The figure shows weekly index for transportation equipment. It is well known that a major typhoon caused serious damage to some factories in the transportation equipment in October 2019. The sharp decline in the offshore statistics is vividly captured by our index. Well, next I will talk about the conclusion and key takeaways. The takeaways are simple. Mobility data certainly has information about economic activity. It can be useful if we manage to extract related population fluctuations using other data or statistical technique. There are several caveats. One thing I want to emphasize is that we can't detect structural changes without other data. Suppose there is a relocation of a large factory, which will result in a sharp drop of the index. Without additional information, however, we can't be sure about whether or not such movement is driven by weakening of real production activity or not. This is the end of my presentation. Thank you very much for listening.
Thank you. Our discussant is Shirley Zhou from Hong Kong Baptist University.
Okay, thanks, Prof. Dan. So maybe let me begin my discussion. So firstly, thank you very much, Prof. Dan, for letting me to discuss this very interesting paper, Nowcasting Economic Activity with the Mobility Data. So firstly, because Yusuke has presented this paper very well, so I will just briefly go through what this paper has done, and then I will share some of my opinions, hopefully can better develop this paper. So firstly, what does this paper do? So this paper is very intuitive. So it just develops a high frequency index to measure the real-time demand in service industries and also the production activities in manufacturing industries. And how do they do that? They use the very intensive GPS mobility data from a mobile app. So basically, if you use the mobile app and you allow the company to collect your data, then you will appear as one data point in the data. So this data estimates the hour by hour number of people in each 100 by 100 meter square mesh in Japan. And then based on this data, the authors generate a real-time economic indicator, which is called EIG, for each sector at time t as the number of people associated with the activities we are interested in at that time, divided by the number of people at a reference time point is. And when aware, they have 3 years of data from 2017 to 2020, and the location is in Japan. And why can they do that? The logic is also very simple. So we just assume that the population in specified areas, which is closely associated with the activities that we are interested in, can well predict certain economic activities in a timely manner, such as the consumption in the service industries and production in the labor-intensive industries. So this paper is actually closely connected with the topic of the use of untraditional data sets. So actually, this is a very hot topic, and it has been applied both in academic researches and also the real applications. So in academic researches, we have a series of papers talking about that. So for example, the paper of Fruit et al. Show that the real-time potential customer search pattern provides additional information on the firm's earnings. And also Huang shows that we can actually construct treatable investment strategy based on the Amazon customer reviews. And also Drew's paper shows that the availability of the alternative data improves the price informativeness and helps to discipline corporate managers. And our paper shows that the disaggregated sales estimated from the customer credit card spending provide accurate and persistent signals of the customer demand, which is relevant to a firm's stock price. And in reality, the hedge funds are also utilizing those untraditional data sets to actually invest. So the Wall Street Journal shows that the hedge funds use the satellite image to infer the customer traffic at the retailers. And then they construct investment strategies based on that. And the logic is actually very simple to the logic of this paper. And also the New York Times show that there are a lot of technology companies actively collecting individuals' real-time bank account and credit card spending information and utilize those untraditional data sets. So what does this paper find? So the findings of this paper just echoes the previous studies that show that the EIG index generated from the real-time mobile GPS data can accurately capture the economic activities at a timely measure. So they check two different industries, the service industries and also the manufacturing industries. So they show that the EIG closely mimics the population, which is the potential customer patterns in service industries, including the amusement parks, shopping centers, and food service. And also the EIG closely captures the labor input in the labor-intensive manufacturing industries. For example, the transportation equipment and production machinery. But this indicator is less precise for capital-intensive industries. For example, the electronic parts and devices. So here is my comments. Firstly, this is a very interesting paper and it is related to a very hot topic. And most importantly, this method can be directly implemented for real applications. So this is actually a picture I got from the mobile app website. So we can visually see very clearly at each time point how many people are located in where. So very straightforward. And I also have some comments maybe can help the authors to better develop this paper. So my first concern for this paper is the representativeness of the data. So as we know, the population data is collected through the smartphone applications with the approval of the users. So will this lead to potential selection bias? So firstly, how widely is the mobile app used? And also, are those people approved data collection representative of the general population? So these are the two basic questions and actually can be easily solved because if the authors can provide some user statistics and also if they can show the distribution of the demographics for the general population and for the mobile app users, to check whether they are significantly different, then this concern may be kind of mitigated. And the second comment is that it will be better for the authors to give more explanation and justification of the EIG index because this is the major index, but the description in the draft is relatively brief. Okay, so firstly, how is the weight for each mesh exactly determined? And how to disentangle the relevant population from the irrelevant population within each mesh. Because all of the selection are done at the mesh level, but within each mesh, we still have the relevant people and irrelevant people. So relevant people refers to those potential customers or workers, but irrelevant people refers to the people just customers. And also, what is the economic meaning of the denominator, which is the total number of people at a reference point of time? And how is the reference point of time determined? And how can that solve the problem that the set of meshes selected does not necessarily include meshes that cover all the facilities and buildings related to the industry? And this is the rationale provided in the paper that's why they want to scale. And also a real example will be very helpful. So for example, if the authors can show how the indicator of the amusement park is computed. And the third comment is regarding the empirical tests. So currently, most evidences are shown in pictures and most correlations. So if the authors can show more advanced statistical tests, for example, the regressions that can help to confirm and quantify the effects. And also the selection criteria seems to be arbitrary or exposed. So for example, they said that we choose a combination of thresholds of the ratios so that the correlation between the labor input and the population will be the highest. But this can only be done if we know both data sets. We know the population data, and we also know the industrial production data, which is low frequency and comes much later. But if we don't know those low frequency data, then how can those thresholds be determined? And the fourth comment is regarding external validity. So from both the time dimension and cross-sectional dimension. So time dimension is that currently the authors use all data to fit the historical trend. So this means they just show how closely does the indicator mimic the economic activity both at time t. But can we use the EIG at time t to predict the economic activities at time t+1? That will also be very interesting. And for current version, we can actually split the sample into a training period and prediction period. Then we use the training period to estimate the parameters and also the thresholds, and then predict the economic activities at the prediction period. And this can potentially solve the issue of the arbitrary selection criteria as well. And also with the trend of switching to online shopping and capital intensive production, how long and how well can this measure work is also another issue. And also the cross-sectional dimension, this indicator only applicates to limited industries. Is that important enough? And my last comment is about two extensions. So the first one is the potential mechanism. So is that just a more timely measure without any additional information? Because our papers show that actually the customer characteristics and spending patterns offer additional signals to gauge the sustainability of the customer interest. And if we also know similar characteristics of the population, maybe we can also see that there are additional information beyond the traditional measures. And also, can we generate treatable strategy out of the more timely data? So as shown by the Huang paper, if we construct a spread portfolio using the abnormal customer ratings in Amazon, we actually can make money. But can we do that also using the data in this paper? So these are all my comments. Basically, very interesting paper, and I look forward to an updated version. Thank you very much.
Thank you, Shirley. Yusuke, would you like to have a quick response, or you prefer to wait until more questions and comments from audience, then you respond at the end, in the end?
Well, let me brief talk about some comments. Well, basically, all the comments is very helpful. Some of which we try to address, but the major limitation is that we don't have enough information about the identity of the places, which is what the places are about. So I see one comment pointing out that the application of the our methodology, actually these four sectors, which is amusement parks, shopping centers, and restaurants and factories, is what we can come up with. So as Xing pointed out, if we can use some statistical tests or additional techniques, it can be further extended to other industries. Well, thank you very much for your comments.
Thank you, Yusuke. Before I let the audience, panelists to ask questions, as a session chair, I take that privilege to ask the first questions. It's a very interesting data, very rich, and the idea of estimating the index is very useful because this high frequency data can provide a much granular economics productivity index measures compared to the conventional one, like the Bureau of Labor Statistics and Employment Index, right? However, as Shirley mentioned, given there's a wide variety of applications, I'm thinking about applications. When we apply this to study, for example, the consumer index or productivity employment index, Shirley already mentioned about how to screen out the relevant, irrelevant, how to make a clean data cleaning. One issue is if you look at the amusement restaurant, those visitors index, then have you think about how to separate the employees and visitors and diners, right? And then when you think about the unemployment index estimation, there's a new challenge we all know after this pandemic, COVID-19. Some people are working at home. Are you thinking about how to capture those in productivity, not working in the location, but working remotely, like professors teaching at home? So these kind of things, have you discussed or think there's a way to address those?
Well, about the issue of mitigating noises, I think there is no prior method we can use to exclude all unrelated fluctuations. Well, why we believe some, for example, the restaurants, we used clustering techniques, and fortunately, one of the clusters shows close co-movement with our target indicator. So we kind of be confident about the result. But to be sure, the number 5 is kind of ad hoc. It is because if we set the number, you go 3 or 4 or 6, none of this, the cluster shows close co-movement to our target indices. So, well, the mitigation of noise emissions, I think it deserves further research. What we did actually is we impose minimal priors, such as the distribution. You see the distribution and check it's not residential area, and so on. So I think there's really very large room to improve the mitigation of noise meshes. About the second question, about estimating people working in the home, this is we think this is very, very difficult to measure, because what we actually construct is to basically learn the relationship between our indices and the target index from the relationship that is before the pandemic. So it's not we are not sure how the relationship changed after the pandemic, which is a major structural change. So our index is basically some weighted average, and we did a linear average of population. So the change of weight. We need to detect the change of weight, but we don't have enough sample to detect that. So I think about the second issue, it's really difficult to address. Thank you.
Thank you. Any other comments or questions or suggestions from the panelists and audience?
Yasuki, I have a quick question about the data. So, in the mobile, for example, is there some minimum staying requirement for somebody to be counted as appearing in the, the mesh, right? So if some, Shirley mentioned someone passes by, versus someone actually works there for 8 hours, is there some? Does the data allow you to distinguish this type of people?
The minimum number is 1. So
1 minute?
No. It's hourly average people. So if just one people stay in the mesh less than 1 hour, then it's truncated downward. So
no, I think my question is, how long does this person stay in the hour?
Yes.
Does it matter?
Yes, it matters because it's basically hourly average population. So if on average the mesh have 0.6, only 0.6 person in that mesh, it will be 0. So to answer your question, there is no lower threshold to correct the data.
Okay, no minimum time requirement.
Yes.
Could you comment a little bit about the availability of the data? Is this, I always had the impression you had to have a special relationship with a phone company to get this. Is that?
Well, there is a test. Well, we are another paper comparing the GPS data with offshore population statistics. Well, actually, the data is gathered from 1.5 million samples, and it's expanded to match the distribution of the whole Japan. But as you can see, in urban area, the sample is quite abundant, but in rural area, it's not. So the accuracy.
But in Japan, the data is freely available.
Yeah.
It's made so they make the data public.
No. We have it's proprietary data, and it's quite expensive.
I see.
I'll ask a quick question about the data. How much stability is there in the data? Do people rotate in and out of this panel over time, or do you see the same individuals for multiple weeks or months in your data set?
Well, that's a good question. So, the data is a panel data about places. So you can't be sure if one person is on the sample pass for how long they appear in the samples. You can determine this, and the data can be seriously affected by the collection process of the data. For example, if the company selling this data adopt other apps and starting to collect the data from the new apps, then it should be some jump, with some discontinuity in our data. But fortunately, we can't detect such major discontinuity in our application. But you should be very careful about such potential or structural changes.
Can I ask another question?
Yeah.
Hank. So you're at the Bank of Japan. You should have inside information on this. I'm wondering, the central banks have become very good with their nowcasting models in predicting economic activity, inflation, etc.
Yes.
I'm wondering how this approach compares to what the bank is currently using rather than other indices in the out there. In other words, how much of marginal value there is in this for policymakers, monetary policymakers. Do you have any insight into that?
Well, we have some nowcasting models about using traditional data. So the thing is that when there's pandemic, we can't be sure about which direction the economic condition will move. So having additional indicator is really useful for, how to say that, to make you confident about your forecast about economic activity, especially under sudden change, like the pandemic. So it can be the main tool. It can be the main tool for evaluating the economic situation because it has a lot of limitations as we discussed. But it certainly can be helpful when there is a major structure change, sudden structure change in the economy.
Thank you.
Thank you. Other comments? Yeah, following up with Stein's question about a 1 hour thing, or Hemming or Stein, I forget. Is the data vendor set up this 1 hour ban? Because I'm thinking if you look at the consumer index, like those amusement park, people tend to move around more than 100 meters quite frequently.
Mm-hmm.
And it's very difficult to stay for one. So can you ask the data vendor to set the duration to 30 minutes or 10 minutes, or that's the data, whatever it creates?
Oh, well, if one person stayed in a mesh for just 30 minutes, then it will count at 0.5.
Okay.
So their movements in the amusement park will actually will be captured in the if we correctly
Okay.
specify the meshes. Yeah.